Welcome back. We are joined today by Charmaine Berg. She is the grade 6-7 teacher from McGowan Elementary, whose class has just been informed this past Friday that their science experiment is going to be launched to the International Space Station. Charmaine, congratulations.
Thank you so much. It's such a wonderful opportunity.
It is so. And of course, it's always lovely to have you back on the show, Paul, from Bert Edwards, the principal at Bert Edwards Elementary. Great to have you here.
Thank you, Susan.
Yeah.
Good to be here.
Who'd you beat out? I know it came down to 3 classes in Kamloops, but this was a huge thing.
It was. One of the experiments had to do with tooth decay in astronauts, and the other experiment had to do with density, like separation of liquids.
So those are the 3 Kamloops schools.
We didn't actually get to look at the experiments or their proposals, so we only had their title to figure out what they had done. So,
what is your experiment all about?
Our experiment is on crystal formation in space. It came about kind of triggered by a grade 7 chemistry concept. In a chemical change, when 2 liquids come together, they make a solid. That can be a sign of a chemical change having happened. One of my students was very intrigued by that whole concept, and he chose to pursue it further. And that's kind of what spurred on the idea.
So that is something that the whole class sort of got together on and made this sort of project come together.
Well, what I did is we talked as a class about all the different possible topics that they could investigate. We had kids investigating antibiotics' effect on microorganisms. We had other kids who looked at sprouting of like alfalfa sprouts, if that would be affected. We had another group that looked at paint, if paint would dry in space. Like they thought about putting paper inside and putting paint and seeing if it would dry. And then another group that talked about composting with worms.
Really?
So there were lots of different ideas.
We would love to hear more about when is this going to be launched into space. Of course, that International Space Station, we're all sort of familiar with how it looks a little bit. We got some shots here. When is this happening?
So I can speak a little bit to that, Susan. It's slated for launch in the fairly generally stated fall 2014 because of the nature of space launch and space flight. Even if this was an actual NASA mission, and this is a real mission, but this isn't what they would call a high priority mission. Even those launches get delayed for all kinds of reasons: weather, staffing, feasibility of their experiments. So we are pretty low on the priority list. So we are at the mercy of all these other events that might bump us. So I think historically, of the last 5 missions that have gone, very few of them have gone on time. So we have the very general fall 2014. Sure. It may end up being January, February 2015.
Right.
But as far as I'm concerned, if we're getting our experiment into space, you notice how I said our experiment. if we're getting our experiment into space. That's all that matters. Whenever it happens, it's going to happen according to their schedule. So.
Absolutely. And tell me this, will we all be able to see the astronauts doing the experiment? Will that at all be no, it won't be recorded? No, not even a picture will be taken up there at the time?
No, and that was one of the difficulties when we were designing our experiment, is the fact that there would be no observations at all that took place while on the space station. The tube goes into 2 different layers of bagging. And again, that's for protection, so nothing escapes, because in the International Space Station, anything that's loose or could possibly get into anything is a problem. So they double bag it. And not only that, it's opaque, so you can't see through the bag. So they have to release the clamps by feel, because our experiment has clamps on either end. They'll have to release that by feel. So that was one of the obstacles that we had to discuss when we were creating our different projects about how this would happen in those restrictions.
Are there many steps involved in what they have to do while they're in space to this tube?
No. The experimental design is that we'll have it ready. We will have 2 clamps. So there'll be a middle and then 2 ends. There'll be liquids in each of the chambers. They'll release both clamps. As soon as the first interaction, they'll release both clamps, let the solutions come together, and then in their last interaction, so before it comes down, like comes back down to Earth, they'll put the clamps back on.
Okay.
And then we'll get whatever has happened.
And I apologize, the last time I was on, Susan, you'll remember that I actually had an example of the device called an FME, which is essentially, it's about a 15 to 17 centimeter long silicone tube that's less than 1 centimeter in diameter. It's got a plug in each end, so we preload it with the student's experiment, and it then has 2 clips that essentially separates the volume into 3 compartments. And all the astronauts will do is remove those clips to allow mixing. And then after whatever time period your class specifies, they then put the clips back on. And we would have it here to show you again, except that Charmaine had to use it to do her dry run because we had to do a dry run to make sure for NASA that there was no heat issue. They wanted to know about heat generation. So.
All right, that sounds pretty exciting. Tell me this, fundraising, of course, had to take place because to get this 13-inch little tube up into space, it cost $21,000?
$22,400 US,
That's
which
expensive.
I think at current conversion is just over 25,000 Canadian.
And you've raised the cash.
We are just so close. And it isn't just me. I mean, I certainly have spearheaded the effort, but I've had a little bit of help. And we just actually on Friday got our final contribution, a very generous contribution from TELUS that should put us at the mark that we need to be.
That's amazing. So you can have that little piece of it out of the way and now just look forward to finding out when things are going to happen.
Little piece of it, yeah. It's funny that you call it a little piece because the fundraising has dominated my life for the last 3 months.
I bet it has.
So it's nice to have that hurdle over.
The $22,000 hurdle has now been passed. So yeah, good for you. Congratulations.
Thank
and congratulations to you.
Thank you.
Your kids must just be stoked. And,
they're so excited.
And you know what? I would like to think that something like this would have a real influence on some of those kids, and who knows where their futures are going to end up now. You know, they might really want to pursue a career in science as a result.
It promotes
They'll never forget
aspiring to something maybe that they wouldn't have before.
And I think that is the bigger thing here to think about, is the win for these kids in the end. So pretty cool. Yeah.
Well, and the really neat thing is that I mean, I'm sure you'll agree, Charmaine, to get kids interested in doing something hands-on, it has to have purpose. And for these elementary school kids to have their purpose being, my experiment is going into space, like it doesn't get any more purposeful than that.
No, it doesn't.
Yeah.
No. Well, thank you to the both of you, Charmaine and Paul, for appearing on the show today. Congratulations. And it's so great to see all of this come to fruition and see the end result. So we'll look forward to seeing what happens in the fall.
Thank you.
Very exciting. Thank you.
Okay, so welcome. We're going to take a quick break. More Midday when we return. Stay with us.